This is the Unit 10 second semester final review. We're now looking at number 18. So we first have to simplify with no negative exponents. So I'll just kind of first look at this, and if it's a negative, I'm going to move it across the fraction. So the x squared is going to stay there. Y to the negative fourth, I'm going to move down, makes that positive. X to the negative third, I'm going to move up. And y to the negative sixth, I move up, makes them positive. So from there, I can start to piece them together. I have x to the fifth on top, because I have 5 x's. And then I have y to the 6th and y to the 4th. Well, there's 2 more y's on top, so I'll make it y squared. So it's x to the 5th, y squared. For b, I'm first going to have to distribute this cubed out inside the parentheses. I get negative 2 to the 3rd, a to the 3rd, and then b to the negative 2 to the 3rd becomes b to the negative 6th. Now when I bring down everything else, I see I have a negative 2 to the 3rd, which is negative 8. That's going to go out in front. I have an a to the 3rd and a to the 3rd, which becomes a to the 6th. And I have b to the negative 7th, negative 6th, and to the 1st. So in combining those together, I get negative 8, a to the 6th, b to the negative 12th, which I'm now going to move that underneath and make it b to the 12th, making it positive down below. For 19, I have to simplify to have no radicals and have rational exponents in the form a to the exponent b to the c, b over c. So this x to the 2/3, the 6th root means 1/6, and so I'm going to multiply these two because it's an exponent to an exponent. 2/3 times 1/6 becomes 2 over 18, which is 1/9, so I make it x to the 1/9. 6 to the 1/10 times 6 to the 3/5. Since they're separate exponents, I'm going to add 1/10 plus 3/5, which I can make 1/10 plus 6/10, and this becomes 6 to the 7/10. For c, I'm going to multiply because it's an exponent to an exponent, so it's 1/3 times 2, or 2 over 1. That becomes x to the 2/3. Number 20, I have 16 to the 3 over 2. I could write this as 2 ways. I could write it as the square root of 16 cubed, or it's 16 to the 3rd, the square root. The one on the left's a little bit nicer because the square root of 16 is 4. That becomes 4 to the 3rd, and 4 to the 3rd is 64. On b, I'm going to rearrange the order, and I'm going to make it now the cube root of 27 squared. Because the cube root of 27 is 3, 3 squared is then 9. For 18, 18 is 9 times 2. So I can take the 9 and notice that it's 3 times 3. I can take those out and write it as 3 root 2, and that's what we call simplified radical form. Now we look at 21. We have root 3, root 7, square root of 11, and square root of 13. I need to figure out if their statements are true or false. Are they all real numbers? Yes, they are. That's true. Are they all rational numbers? They are not. They are not rational because we call them irrational. So that's going to be true. And are they integers? Integers are typically, we think of as whole numbers. These are not. They don't simplify. If they were perfect squares, yes, but not in this case. 22, I need to simplify and leave in radical form. So when I have numbers on the outside, I'm going to multiply them together. And when I have numbers in the radical, I'm going to multiply them together. So 5 and negative 2, I make into negative 10. 3 and 7 go inside, I make it into the square root of 21. Square root of 21 doesn't simplify, we leave it as that. Next one, I have negative 5 and 7 become negative 35. 12 and 3 is 36. Well, that actually simplifies because the square root of 36 is 6. So now my answer is going to be, oops, should have brought 35 down, not a 36. Now it's going to be 35 times 6 and a negative 210. For this one, I'm going to divide. 6 divided by 3 is 2, and then 45 divided by 5, as long as it's in the radical, is a 9. But 2 times the square root of 9 is 2 times 3, and we get an answer of 6. For For D, I'm going to combine like terms. I have 8 and 5 is 13. Now, I'm really looking at the coefficients on these. I'm not going to make it root 6. What I'm saying is I have 2 root 3s. So I'll write it as 13 plus 2 root 3. E is a little different. We just got to make sure we distribute out the negative. I'm going to make it negative 5 plus 2 root 13. It's really, are you paying attention to that second negative in the subtraction? 7 minus 5 is 2, and then negative 9 and positive 2 is a negative 7, so it's going to be 2 minus 7 root 13. 23, all of them have the same base. It's 11 to the 3/5 times 11 to the 4 over x equals 11 to the 7/5. So in doing that, I can just make it into the equation 3/5 plus 4 over x equals 7 over 5, because these exponents need to add to equal that one. So we drop the base off of there, and we look, well, 3 and 4 add to 7, but that's only going to work if this is 5 and they have like denominators. Since that's the case, we're going to say x equals 5. For B, I'm going to first change them all to exponential. I have 7 to the 5 over 12 over 7 to the 1/3 equals 7 over 1 to the x. Now, when it's division, I can make it into subtraction. So that's 7 to the 5/12 minus 7 to the 1/3 equals 7 to the 1 over x. I'm not real sure what that denominator needs to be, so I'm going to make this into a like denominator, and maybe I can simplify. So that needs to be over 12. To do that, I multiply it by 4. And now I have 5/12. It would be 5/12 minus, really I should drop these off here and just have, got ahead of myself, just looking at the exponents if I'm getting rid of those, because it's not really subtraction. But 5/12 minus 4/12 equals 1 over x. Well, 5 minus 4 is 1, so 1/12 equals 1 over x. X should equal 12. In number 24, we need to select all the equations that are equivalent to what we had here. So I'm going to first kind of play with this one and make it 8 to the 2/3, and that's going to be x to the 4/3. 8 to the 2/3, I could take the cube root of 8, and that's 2. So this could be 2 squared or 4. And that's going to help me and go through and eliminate some answers. So I want to look for ones that have constants of 4, and those are going to work. Or I find the ones that don't, and I can just eliminate them. Like this one right here, I have the cube root of 8. That is not going to come out to 4. That'll come out to 2. So that one's gone. This one's going to be the cube root of 2. That one's not going to work. That one has a 4. Okay. That one has a 4. All right. This one, I'm going to take the cube root of 8, get 2, square it, and it would come out to be 4. So that one's a maybe. So those are the ones that at least work. Now, I go to x to the 4/3. This is x to the 4 over 3. We said it worked already, so we'll take D. This is 4x and x to the 1/3. Together, I have 1 plus 1/3, which is 4/3. So that one is true. And here, I have x to the 4th, because it's x squared squared. And then the cube root becomes 3. That'd be x to the 4/3 as well. So we'd say A, C, and D. Again, I recommend on this one, eliminate the ones you know don't work. Start with like the constant out in front, the coefficient. It makes it a little bit easier to clean up. Next one, let's look at simplifying. Both of them are going to have the 4th root. So let's go 2 to the 1/4 x to the 2/4 times 2 to the 1/4 x to the 3/4. Now, I can put these together, and that's going to be 2 to the 2/4, or 2 to the 1/2. I can put these together, and that's going to be 3 to the 5/4, or x to the 5/4. I don't know where I got 3 from. So 2 to the 1/2, x to the 5/4, that actually matches B, because they actually didn't reduce the 2 over 4, and that's the one we want. We'll go to 26. Now I'm going to multiply these out in front, and that's going to be 1/9, and it's going to be x to the 1/4 plus 2/3. So here, if I add 1/4 and 2/3, they need to have a denominator of 12, so that's 3/12 plus 8/12, which is 11/12. So I got 1/9 x to the 11/12, which I could also maybe see as 1/9 the 12th root of x to the 11th, which I see there as answer C. For 27, I'm going to write them all in exponential form. So I got x to the 1/3 times x, or 8 to the 2/3 plus 8 squared. I'm then going to distribute in these by adding exponents. So I get 8 to the 1/3 plus 2/3 plus 8 to the 1/3 plus 2. This becomes 8. And then here we have 1/3 plus 2 is really 1/3 plus 6/3 or 7/3. So looking through, I got a 8 to the 7/3, 8 to the 7/3. So those are at least in, but I need an 8. Well, this one, trying to trick us, is actually 8 to the 3/3. It would work. Our answer is going to be C. For our next one, we got 5 to the 3/8 times 5 to the 2/4. Let's combine those. I could write 3/8 plus, let's make that 8s and make it 4/8. So that's 5 to the 7/8, which is the answer of D. For 29, we have the numbers 2, 7, root 2, root 7, 2 root 7, and 2 minus root 7. Choose two numbers that when we multiply them, it is irrational, and when you add the same two numbers, it is rational. So we need to multiply to get an irrational, but add them to get a rational. Well, I know I'm not going to use my whole numbers. If I'm multiplying to get an irrational, they need to be square roots. But if I look at root 7 and 2 minus root 7, if I add those together, that leaves me with a 2. If I multiply them, it gives me 2 root 7 minus, looks like 7. So those two would work there. B, multiply them, it's rational, but add, they're irrational. So I want to look to, I can multiply, and it gets rid of the square root. In that case, I see root 7 and 2 root 7. Because in multiplying those together, it comes out to be 14, because it's 2 times 7. But in adding them, it's going to be 2 root 7 plus root 7. It'll be 3 root 7. For C, I multiply them, they're irrational. I add, they're irrational. So when is it not going to work? Well, root 2 and root 7 seem to fit that. When I multiply them, it's the square root of 14. When I add them, it's root 2 plus root 7. It's also irrational. So those are the ones that fit. For number 30, we need to choose all false statements and then correct them if it is false. So what we'll do is we'll simplify, see if it works, and if in doing that, if it turns out false, we'll have the correct answer. So for A, I have x to the 6th over x squared. In doing that one, I'm going to simplify it. I have 6 on top, 2 on the bottom. That's actually x to the 4th, and that is not equal to x to the 3rd. So that one is a false. It should be x to the 4th. For this one, I have y squared to the 4th, so that means I have 4y squareds, so I have y to the 8th, and that is not equal to y to the 6th, so that one is also false. B to the negative 3 means if it's negative, I move it underneath the fraction to make it a positive exponent, then that is not true, so that one is false. For D, I'm going to distribute the exponent out. X to the 4th is x to the 16th. Y to the 3rd to the 4th is y to the 12th, and then I have an x to the 4th. I combine the x's, and I get x to the 20th, y to the 12th, and that one does turn out to be true. And the last one is b to the negative 5 to the 4th, means I have b to the negative 20th, and that is not equal to b to the negative 1st. So A, B, C, and E are all false. Let me move that one over. There we go. Okay, simplify the expression, then select the ones that are irrational for our last one here. I'm going to multiply. I get 15 times the square root of 36, because that's 2 times 18. That's 15 times 6, which is 90. So that comes out to be 90. That is not irrational. 7 times 36, square root of 36 is 6, and that comes out to be 42. That is not irrational. When I divide root 15 over root 3, I'm left with root 5, and that is irrational. 4 times, I'm going to write this as the cube root of 27 squared. The cube root of 27 is 3. 3 squared is 9, so I get 36, and that is a rational number, or not irrational. The last one here, I can't really combine these two. I guess I could go like 3 root 2 and make this a, let's see, root 18 is 9 times 2, so that's 3 root 2. So I could go 5 times 3 root 2, make it 15 and 3 is 18 root 2, but that is just going to stay as irrational.